Now we are using the function hcluster. Hclust is for hierarchical clustering. We are trying to run hierarchical clustering on these distances, and we are here trying to use complete linkage. We've already discussed about single linkage, complete linkage, average linkage, and centroid linkage. And your complete linkage would always look at your farthest neighbor. Yeah, this also we have already discussed as part of the previous tutorial. So let me run this. So I have loaded the output of hierarchical clustering into an object called fit. Of course, you can try out single linkage, average linkage, centroid linkage, all of those. You can. You're just a question mark away. If you do a question mark, you will get to see the help function in here. Look at that. You can either go with a single linkage, complete linkage, average linkage, centroid linkage, median, so on and so forth, right? There are a lot of other things, but we predominantly discussed about 4. Now if you run this function called plot of fit, you should be able to see dendrogram. This is the dendrogram. So if you clearly notice here, universities 2 and 10 are clustered together. Universities 9 and 25 are clustered together. But I think I can, arrange it in much better way. So for that I will say plot the same hierarchical clustering output, but say hang equal to -1. Now look at that. Earlier it was like that. Now hang equal to -1 has arranged everything in the same horizontal line there so that it's easy for your viewing. That's it. It's just easy for your viewing, and that is your R function. People have written R code, R programming language have written in this way. Yeah. So if you notice this clearly, you get to see that 2 and 10 are clustered together, and the distance between 2 and 10 is given using this line here. Distance between 9 and 25 is given using this line here. And this 17th university seems to be closer to 9 and 25. And 17, 9 and 25 are clustered together. 15, 17, 9 and 25 are clustered together. University 6 and 7 are clustered together, so on and so forth. Now, if you say, hey, using this cluster, upfront we will not determine on how many clusters we want. We are instead going to look at this dendrogram and then decide on how many clusters we want. And if you look at this, we are saying that, hey, 5 clusters seems to be reasonable, and you're using that cut tree. Let me run that. And you have come up with groups, right? So using this, you have created 5 clusters. Probably this is one cluster, right? And this could be second cluster, third cluster, fourth and fifth. Yeah, in that way, probably. We don't know. Let us see. And question mark will only help you, get better insights. But you can also give a border, a rectangle for each of those clusters. Now you don't know, right, which university forms which cluster. It was visually very difficult. So if you just add an argument called border equal to red, each cluster would have a red border, and the function that you need to use is rectangle.hclust. I've run this. There we go. So we have 1, 2. This university 3 is a standalone cluster. It's not clustering with anyone. This is your third cluster, which includes 21, 14, and 24. 16 and 18 are part of first cluster, and you have your fourth and fifth cluster subsequently. So this is how it will make our life easier, this function, to differentiate between the different clusters. Now I want to copy all of these clusters. For example, look at this. the first entry or the first university is assigned to cluster 1. Second university is assigned to second cluster. You can view all of those here also. So let me select this and say groups. Look at that. We have 25 universities. First university belongs to first cluster, second belongs to second, third university belongs to third cluster. Fourth university belongs to first cluster, so on and so forth. 25th university belongs to second cluster. Now this is fine, but I want to create a matrix of these groups and assign it in an object called membership. Matrix is a simple, so if I click on that, right, this is a matrix. Yeah, 1, 2, 3, 4, it's a column. It's probably some kind of a neat structured format. And now I'm merging this particular new column that we have with the existing data set, which is my data. So for my data, I'm adding another column called membership. And what does membership hold? Membership holds all these cluster details in a column. And I'm assigning it using an assignment operator to an object called final. So let me do so. There we go. Now if I click on final, you would be able to see the last column which has the name of the university. So Brown belongs to first university, Caltech belongs to second university, CMU belongs to third, so on and so forth. So Brown, Columbia, Cornell, Georgetown all belongs to the first cluster. 1, 1, 1, 1, so on and so forth. Now, rather than having this particular column towards the end, can I bring it towards the start so that I might have the membership ID and the university just beside one another? So I'm running this function. This is rows comma columns. Once again, you can just spend some time analyzing. You'll come to know it is rows comma columns. So here we are saying that we want all rows, and you're saying that combine all the columns of this final data set. You want all the columns, and 1: you're taking n minus 1. So number of columns of final are 8. So 8 minus 1 would be 7. So you want all the columns comma only 7. What this does is, this is going to first take all the columns. So you will have columns from 1 to 8. And then it is going to move from column 1 to 7. When it does that, and when you want these two combined, it takes the last column and replaces it and places it in the first position. So if you look at, let me run this. So you have a final one here. If I click on that, the column which was here towards the end has come to the first now. That's the objective of that function. And then finally you can read this to an Excel file and you can save it for your further analysis. We can do a bunch of other things, right? We can also install a package called data.table and try to explore further in repositioning the columns in R, but that's fine. Let me run this. There we go. I want to know what is my current working directory. So I will say get working directory, users, and here I should be able to see what was the name of that. Final one. Here we go. Final one dot, I believe it's XLSX. Fine. Here we go. So we have the membership ID and the university name. So we know which universities belong to which cluster. Of course. We've also discussed that until and unless we can name a university or you can name a cluster, your clustering exercise is not done. So maybe given an opportunity, I will filter and probably try to filter and see only 2 and see what are these universities. If you look at this, you have Caltech, you have Duke, Dartmouth, Harvard, Johns Hopkins, MIT, Princeton, Stanford, Yale. These are all your tier 1 universities. So probably I would give this a name called tier 1 universities, right? In that way you can do a drop down on each and every cluster and just try to evaluate all of those and give a meaningful name to each and every cluster. This brings us to the end of hierarchical clustering, and as part of the next discussion we will discuss about k-means clustering.